Modernization Strangler Pattern with Jay Tower.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture and engineering firm that empowers .NET teams and executes big, complex software projects that are too big and too risky to leave to chance. My architect forums are going strong. Signups for the next session are up, and if you lead a software team and are looking for peers to collaborate with, then just go and sign up at the link in the show notes. And for those of you looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. Now, my guest today on the show is Jonathan, or Jay Tower, as he's known to his friends. He's a husband, a father, and the owner of Trailhead Technology Partners, a custom software consulting company with employees all over the world. And he's also a Microsoft MVP in the .NET category, and he frequently speaks at software meetups and conferences. And he doesn't mind too much the traveling because he loves sharing what he's learned, and it also gives him an excuse to visit any nearby national parks, which is a passion of his. And that's proven by the fact that he's currently made it to 56 of the 63 parks. It's impressive. Jay also has a passion for building community, and he served on several nonprofit boards over the years. And currently he sits on SoftwareGR, the board of that, a nonprofit trade organization that's dedicated to building the software industry in West Michigan. And he also runs Beer City Code, which is a software conference, and he served as president of that board for over a decade. He loves hiking and reading and photography and trying to see all the Best Picture nominees before the Oscars ceremony. So Jay, welcome to the show. Good to see you. Thanks for being on.
Good to see you too. Thanks for having me, Jeffrey. I appreciate it.
My pleasure. My pleasure. So quite a few people have seen you at various conferences, including the recent Kansas City Developers Conference there. But for folks who haven't been able to see you speak or meet you, or you're familiar with you, would you mind kind of going back in time and sharing maybe some of the high points of your career that have kind of led you to what you're working on these days?
Yeah, sure. So I'm one of the rare folks, maybe a little less rare today, who knew what he wanted to study in college and then started actually using that. So I got a computer science degree and then started kind of in the late 90s and early 2000s, kind of at the end of that .com era, and did a lot of web development. I remember it kind of fondly early in my career. There was 2 projects in my very first consulting company I worked for that I was going to get placed on one or the other of those. Mm-hmm. One was a Java project and one was a .NET project. Not .NET. .NET didn't exist quite yet, but it was a Microsoft classic ASP project. Mm-hmm. And I do kind of look back at that and wonder sometimes what would have happened if I got placed on the Java project instead. But I've done a lot with Microsoft technologies, .NET over the last 20 years or so, and kind of worked my way up to being a software architect. And then about 8 years ago, started my own consulting company that you mentioned in the intro called Trailhead. And we do custom software application development. So of course, running that, I've gotten a little bit out of the day-to-day, but I still really love the technology, still love learning about it and sharing it with people at conferences and other kinds of events all over the country and all over the world.
Nice. So you mentioned the term architect, and from time to time I like to ask, just because I don't think the dust has settled, for your career progression, starting out as a full-time coder, what does that mean, and what is a software architect?
Yeah, great question. And I think if you asked 10 people, you'd get 11 different answers. to that question, but I kind of see it as fitting into one of two different categories. There's kind of like an enterprise architect, which I think of as kind of like a flow diagram drawer. And there's kind of the software architect, which is more somebody who thinks about how all the pieces of a piece of software fit together and how they should be designed, how object oriented could be used, how n-tier architecture or cloud resources or all of those different types of things could be used or leveraged to make that software more maintainable, more consistently reliable, et cetera, et cetera. So I kind of was that latter type. Never got to the point where I was at the 30,000 foot view over an entire enterprise with all these different systems talking to each other, but more of like focused in on a particular piece of software and how it talks to other systems.
Mm-hmm. Awesome. You've done some speaking and recent work just thinking through methods of modernization, and you spoke at the Kansas City Developer Conference on that topic. Some of the younger developers, they're in the mindset of, I'm building new applications. But at some point, everybody's going to land on a significant software system that they didn't build. And it's been there a while. And you got to figure out what the heck to do with it. How do you bring it forward? And of course, the inexperienced people just start waving the banner of, we need to rewrite this. Talk about your philosophy on maybe when you would actually think, maybe we should rewrite this versus no, not in a million years. We need to figure out how to move it.
Yeah. So it all depends on the goals, the goals of the business or the organization or the team or the users of that software, in my mind. So when we have a client that comes to us that says, hey, we have this application, we want to replace it, that's often, that's an interesting conversation to ask some more questions about, but that's starting with a solution. It's starting with the replacing it instead of starting with the why are you wanting to replace it. And usually we'll start asking questions and we'll kind of get to that why fairly quickly. Sometimes it's a really good reason, like, it's not scaling well, or it's extremely difficult to maintain, or there's 100 other reasons that could be good reasons. And then sometimes it's bad ones. Like people have told us that it's bad and we just kind of assume that is true. And so once you kind of drill down on those reasons, if they kind of add up to it's worth it, then what we often do at Trailhead is we'll kind of do an estimate of what it would take to continue to maintain things and get it to do what they're wanting it to do, but based on the current legacy technology versus doing it from scratch. And if it ends up, sometimes if you have a legacy thing that's really difficult to maintain and it's getting hard to hire people to maintain it and that kind of stuff, it actually makes more sense and ends up being cheaper to rewrite it. And then we'll recommend that, but we'll recommend it for, real reasons, not just because it's more fun to do new software.
Yeah. How often do you encounter scenarios where the recommendation to rewrite it was really born from the individual's developers just inability to conceive of a method that they might be able to upgrade, and so they just throw in the towel?
Yeah, I say it's really that's really common. But on the flip side, it's really rare that somebody like an engineer that's hands-on with a system would be complaining about a system for no reason at all, if you know what I mean. Usually their complaints are based in some kind of reality. Like, yes, it is really old. Yes, it is hard to find people to maintain it. Yes, it's difficult to edit anything without breaking something. Those things are often true. It's just have they thought through all the different options of how they could go about maintaining it, or how they could maybe gradually migrate it over time instead of, trying to do it all at once and in an overwhelming way that's super high risk and, not very agile.
Yeah. So take the scenario where regardless of why they want to upgrade it, it's just a really big system. And you're thinking of, how do we do this all at once? It's just too big. You talked about the Strangler pattern in Kansas City, but what are the options that you think about when there's just something that's really, really, really big and doing it in one big bang is not even conceivable.
Yeah. That's such a great core engineering question, I feel like, which is totally something that I think software architects should be thinking about. And the classic answer, which I think is a pretty good answer in this case, is to break it down into small pieces, right? If you take too big of a bite, you'll choke on it. You want to take smaller bites, something that you can manage. It's also a much more agile approach, taking small incremental improvements over time. The hard part about it is that, especially if you're maybe inexperienced or you uh, maybe you're on a small team and you're kind of overwhelmed with, maintenance work or something like that, it can be difficult to conceive of how you could do that with a really large application. Maybe it took you years to build it in the first place. So it's kind of hard to conceive of an approach if you haven't seen it done successfully before, or how to, break that up into small pieces in a useful way, right? Like I've had a lot of people ask me, okay, we could do this gradually over time, but then we're still going to have to wait until it's all done before we launch it. Sometimes that's just a failure of imagination for how to, break it down into useful pieces.
Okay. And so you mentioned the Strangler padding a few times. For those who haven't read, I guess, what the original write-up, whenever that was, what the heck is that?
Yeah. So the Strangler fig pattern is based off of a plant that I believe is in Australia or New Zealand. I can't remember which one. It's called the Strangler fig. It's vine, and it has kind of a unique way of growing. I'm not a botanist or biologist or anything, but I'll take a stab at explaining it. So as I understand it, birds will pick up the seeds because they've eaten the fruit or whatever, and they will carry those seeds, and then when they drop them, they'll get lodged, somewhere up high in a tree. That will start growing a vine out of that seed, and it'll kind of wrap its way down around a tree and eventually sink into the ground and kind of wrap around the roots of that tree. Eventually, that kind of chokes out the tree. The tree can't get the resources anymore from its roots. Mm-hmm. And so the tree dies. And here you've got this Strangler fig now that's basically using it like a dead backbone just to kind of reach up to the canopy and get the sunlight. And so it's kind of a slow motion, violent analogy, but I think it's an apt analogy for, very slowly and gradually replacing something legacy, in this case, the tree, with something new, in this case, the Strangler fig vine.
Okay. So it sounds kind of morbid, but how does that turn into a strategy for a software upgrade?
Yeah. I always like to joke that one of the approaches for software migrations is to lock everybody into the big conference room and not let them out until the migration is done. Just slide pizza under the door occasionally. And it's kind of a joke, but I've also kind of been in situations somewhat similar to that. Of course, they let us go home at night, but I've been in those types of situations. Probably a lot of us have. It's not very agile. Right. It's what you might call like a big bang approach. If it's a really small application, maybe that makes sense. Mm-hmm. But for a huge application, you're going to be in that conference room for months or years, maybe. Mm-hmm. And the risk is significant if you basically go from 0 to 100% and then just release it. And nobody's had a chance to test it, to use it in real life. Is it really going to scale well? How's the performance? Mm-hmm. Is it actually what you wanted to build, or did you just rebuild what you had before and it has all the same problems that you had before? All these like non-agile things that you don't want to be doing.
Yeah.
Not to mention it's a terrible experience for everybody locked in that conference room. So the Strangler fig works really well because it's gradual. And if you play your cards right, you can actually start to release things in a much more agile way, very gradually release little bits of functionality that are on your new platform, new technology stack, and have them kind of integrated with your legacy application so that hopefully your users are none the wiser that they're using a new app in an old app. Maybe you've seen this before on things like Google often will do this, where there'll be a little link up in the top right of the application that says, click here to try the new beta version of this. And once you get into it and everything is not working right, you can click that link again and get back to the classic version or whatever. So that would be one experience. Another one would be even more invisible to your users, where they're none the wiser, but they're kind of going from page to page and they're kind of switching between legacy and modern back and forth all the time. And if you integrate those correctly and make it a good experience for your user, they won't know that behind the scenes you're kind of gradually moving that functionality over.
Yeah, that's interesting. Which is a different approach from just trying to port the whole thing at once. Because you got rewrites where, okay, you're replacing it, but then, like, I think of the technology port sometimes where now if you're going from an old Windows app and you want to actually get to a web app, there's a whole lot of like redesign because the whole paradigm is different. But if you're going from, let's say, old WinForms, well, WinForms is supported in .NET 7, so is WPF. A port to one of those is a much smaller lift, isn't it? Yep. Because just the paradigm is the same. You could,
that's right. Yeah, I would say if you're going from like a desktop app to a web app or a mobile app, then you're looking at a very different platform and design language and all that kind of stuff. That's hard to do, just a gradual migration. But you might look at like, how could I create a lot of things. I think of like Outlook as a good example of this. There's a web version of Outlook. There's a desktop version of Outlook for Mac and for Windows, and there's a mobile version for Android and for iOS. You could kind of create an MVP or minimally viable product version of your app for whatever platform you're trying to get it to, and release that as soon as you've got that MVP version ready, and then just gradually add functionality to it if you're kind of doing like a major platform shift like that.
Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Well, let's get concrete, because some of the ideas you presented in Kansas City were really interesting, specifically for some older web applications, and that there's some techniques and tooling to make that kind of seamless. What are the big ideas there for an older ASP.NET application and bringing it up to, say, .NET 7?
Yeah. Anybody that's maintaining legacy ASP.NET code knows that, a lot of things are very similar between .NET and .NET Core. The APIs, SDKs, class libraries, namespaces, all that stuff is fairly similar. In fact, you could take most class libraries and just port them over to .NET Core, .NET, and just recompile them, and they just work without changing a line of code, right? But those that have been doing ASP.NET know that ASP.NET to ASP.NET Core is a more significant shift. The actual code, controller classes, if you're using MVC, are going to be similar, but how your startup works, how your configuration works, the pipeline, there's a whole bunch of kind of what you might call fundamental differences between the two. And so it's a heavier lift. And because of that, some tooling to make it something that you could do gradually following that Strangler fig pattern is really helpful. And there's a couple of things that I talked about in that Kansas City Developer Conference talk that you're referencing. The first one is called YARP, which is YARP. And the second one is called the .NET Migration Extension, .NET Migration Tool. So let me talk about the YARP first, which stands for Yet Another Reverse Proxy, which is kind of a fun name. For anybody that's kind of following web development, that it's gotten really popular to do reverse proxies these days for our applications. And ASP.NET Core even has its own that kind of ships with it. That's called Kestrel.
Well, you have to tell
And
us, what the heck is a reverse proxy too?
yeah. So reverse proxies, people who are older like you and me probably remember proxy servers, although the young kids among us probably don't even know what that is. But back in the day, there would be like one computer on the network that would have internet access, right? And if you wanted to have internet access and you were on that same internal network, what you would do is just tell your computer, hey, if you're trying to access the internet, use this other server to act on your behalf. It will proxy your requests out to the internet and then back to you. That's a traditional proxy or a forward proxy. A reverse proxy is just switch the order. Traffic coming in from the internet hits a server that then decides where to forward it into the internal network. So that's kind of what a reverse proxy does. Classically speaking, you can, if you're familiar with load balancing, that you could think of as a specific type of reverse proxy, right? Traffic comes in, it decides this server seems less busy, or this one has gotten a lot more traffic recently than this other one, so I'm going to send this to server 2. And then the next request comes in, and I just gave one to server 2, so now I'm going to give it to server number 1. That would be kind of something that a reverse proxy could do.
So that description would make me think of, say, the ASP.NET Core routing. So
yeah,
is the difference between routing and reverse proxy that routing is inside the memory space of one application and reverse proxy is between machines or between applications?
That's exactly right. Between process boundaries or machines potentially. And so YARP does this really interesting thing where normally if you're going to use a reverse proxy to forward traffic for, let's say, some of your endpoints, you've migrated over to your modern app, and most of them are still on your legacy app, you could set up a third server, right? You've got your legacy app on 1, your modern app on 2, and a third server would be your proxy, reverse proxy. Traffic would hit that reverse proxy first, and it would kind of look at that traffic and say, is this going to a new endpoint or an old endpoint? And if it's new, it would send it to the modern app. If it's legacy, to the legacy app. But YARP does something kind of interesting, which I think is kind of cool, which is that it actually runs inside your modern app, just higher in the pipeline than MVC or minimal APIs or whatever your particular implementation is for your endpoints. So if you've got an API and you've migrated maybe 2 endpoints to your modern app, you've now got only 2 pieces that you have to deploy. Your combination modern app and YARP server or application goes on one resource, and then the other resource will be your legacy application. So that traffic comes into YARP first in the modern app and says, do I know about this route yet in the modern app? And it actually, kind of a cool thing that it does is it uses the ASP.NET routing tables that all of the different ASP.NET technology uses. And it can say, do I know about this? Am I able to serve this endpoint? And if it doesn't know about it, then it'll proxy it through to the legacy app. Otherwise, it'll go ahead and serve it from the modern app. So with literally one line of configuration, you can basically say, if I've got it in this app, go ahead and serve it. Otherwise, forward it through to the legacy.
When you were describing that, I was thinking back to the 2004 book by Michael Feathers, Working Effectively with Legacy Code, and talking about refactoring, just all kinds of refactoring techniques. And the first step in all of them is to figure out how to insert a seam somewhere. Like, the caller and the callee, figure out how to put something in between that does nothing. But now that you have that seam in there, you can start a redirect. And this sounds like that right at the front level between a browser and the actual code that's running the web application.
So if you imagine you had you have a legacy app only, and you want to start this process, your first step is probably going to be some DNS changes, right? You're going to launch your new modern app, but maybe all it's going to do is forward 100% of traffic through to the legacy app. But you need to maybe do a DNS change to just say, hey, this application or this host name is now over here on this new modern server. And then at at the back end of that server, it's just going to be forwarding everything through to your legacy app until obviously you start doing some of that migration work.
So the client browser doesn't know anything. There's no redirect. It's an actual request. That's what in memory being proxied through.
That's right. Yep. So you actually see the traffic coming. It appears that everything, 100% of the requests are actually coming from that modern app. So the responses, I should say, are coming from that modern app. So if you're the client, you're none the wiser that there's actually even a legacy app that exists. You just can't tell.
And one of the tricky parts is cookies and other things that are otherwise saved in the browser that are tied to the URL. Yeah. So with this process, do now both of the applications just get access to all of those? Or do you have to do something specific?
That's a great question. And when it comes to things like session state too, which is sort of, stuff stored in memory on the server, and then things like authentication, those are sort of the trickier parts to integrate. You talked about finding a seam and then kind of inserting the new thing in between. Those are tricky seams for sure. And one of the really neat things about YARP is that it has kind of a sister library that's called the system.web adapters. So everybody who's been doing ASP.NET for a long time knows that in the old days, everything was in the system.web namespace, running in the system.web.dll. And that kind of all went away because that implementation of request and response and HTTP context and all that stuff was highly tied to IIS. And obviously ASP.NET Core can run anywhere. It doesn't have to run behind IIS. So it needs to be independent of that. So that's all been rewritten. But that creates a problem when you're trying to write applications that are still using that code, right? If you're going to move some legacy code over from your legacy app to your modern app, and it's system.web.this and system.web.that, that's going to be tricky. And so the system.web adapters NuGet package that you can bring in has a version that is a .NET standard library. So it runs on both .NET Framework and .NET Core and .NET. And then it's got a kind of a .NET Core version and a .NET Framework version. And these will do a bunch of those seams for you. They'll help you integrate authentication so that the two apps share an authentication cookie. They'll help you do session state in a way that syncs between the two, or use just one as a session server. So a lot of really great stuff. And then one of the kind of cool pieces of magic that Microsoft did with that too is you can actually call system.web namespaces from any of your code. And if it's running in .NET Core, it'll get forwarded to the modern implementation. If it's running in .NET Framework, it'll get forwarded to the actual system.web namespace. So some kind of cool magic in there for you to make that migration even easier.
That is, because I remember with the documentation, there was no abstraction. It was call request, request dot, request open bracket for queries. It was, those calls were everywhere.
Everywhere. Yep. Yep. So if you've got a bunch of that code and you're like, well, it's hopeless, I can't migrate to something modern because this has got system web deeply embedded into it, there is hope now with that system.web adapter library.
Yeah. Yeah. Awesome. Now, how does this work, or how does this look when you're trying to set up your deployment configuration? Is this just a separate web application that can go? Well, if it's a really old application, you might not have moved it to the cloud yet, and let's just assume it's on IIS. Is it another web application that you just put on the same IIS cluster, or what are your options there?
Yeah. You're talking about the modern app. Is it separate? Or?
Yeah, right. You got the new modern app. You got YARP kind of at the front end.
Yep.
What does it look like to deploy that thing?
If you use this tool called the .NET Upgrade Assistant, which is an extension in Visual Studio, it'll kind of set this up for you. So you can basically install this extension. You right-click on your legacy ASP.NET app and say, I want to upgrade this. It'll tell you your only real option is to do this gradually using YARP in front of your legacy app and to gradually rewrite everything and move it over to ASP.NET Core. And it'll basically set all that up for you. Obviously, you can do that yourself as well if you want to do kind of a more of a custom setup, but it'll do that by creating a new project. That's obviously an ASP.NET Core based on one of the more modern versions of .NET, depending on what version of .NET you pick. I think right now the tool supports 6 and above. So obviously we're on 7, and 8 is coming out fairly soon. And so all of those are supported. And it'll set it up as a separate project. Now you actually, I mentioned before, one of your first steps is going to be that DNS change. So because you want the traffic to hit your modern app first, you're probably going to set up a new cloud resource or a new server, or at least a new application on an existing web server or something. You're going to set that up, and you're going to want to forward all of your web traffic to that instead of to where the legacy app was hosted. And then you put one configuration setting in there that tells the modern app how to access the legacy app. Is it an IP address? Is it a host name, internal host name, public host name? Whatever you set up in there, it's basically going to make the requests to that URL or to that IP address to make all of the proxy forwards for you.
Okay. Now, you said the system web adapter, and this is great for ASP.NET, the older ASP.NET. But just listening to the approach, architecturally, does this approach work in modernizing from older or other platform web applications like classic ASP or JSP or Cold Fusion or any of the other ones that were, sprang up and grew big in the late 90s even?
Yeah, totally. Yeah.
Does this approach work for this?
That's a great question. A lot of people will ask me after my talk or in my talk about YARP, is why YARP over the 12 other reverse proxies that are out there. And the big answer to that is if you're a .NET developer, and if you don't want to have 3 separate resources, your reverse proxy, your legacy app, and your modern app, you just want to combine 2 of those to have fewer resources to maintain and deploy. And you're a .NET developer, maybe you want to do some custom routing logic that you want to write in C#. All of that is possible because it's hosted inside of a ASP.NET Core application, because YARP is hosted inside of ASP.NET Core. But yes, because HTTP is kind of the standard that reverse proxies speak when they're speaking to other websites or other proxies, you could have anything that speaks HTTP. It could be Spring platform, or it could be Python, or it could be whatever, right? As long as it's speaking HTTP over the network on your legacy app, you can forward to that and it will work just fine with YARP. Now, obviously, YARP itself, the modern app, would have to be hosted inside of .NET.
Yeah. So if the new application is .NET Core, you have so many choices of old application.
And it's literally anything that speaks HTTP. Yep.
Yeah. I'm even thinking of net new web applications. There's a lot more people that are trying to figure out how to build significant web properties without having it to be one big honking web application. And maybe they already have the ability to split into multiple teams, but architecturally, it just really makes a lot of sense to have the same domain, the same authentication, but maybe, certain paths, certain top level paths be actually different applications. But of course, the DNS and, the browser and all the cross-site requests, and it just wants it to be the same at a DNS level. Is that, am I thinking too far in your opinion on that?
No, not at all. There's this concept called microfrontends you might have heard of, that is kind of inspired by microservices on the back end. And it's exactly that kind of concept. And I think it leverages the idea of reverse proxies pretty heavily. If everyone kind of speaks the same languages, uses the same authentication cookie, or uses something, like SAML or like open API authentication or whatever, then everybody's kind of speaking the same language on the same standards, then you can have different teams writing different chunks of the application and then have it all feel like one application when it comes together behind a reverse proxy.
Yeah, that makes a lot of sense to have one application that has Yarn, the reverse proxy, and the cross-cutting concerns there, but then big major chunks of functionality be in functional applications.
Yeah. Yep.
Of course,
Totally.
you have to have a system that's quite big to start reaching for that without it being just overkill.
That's right. If you're 1 to 5 developers and you're thinking about doing that, I would say rethink it.
Right.
But if you're 150 developers trying to write a system, that could make a lot of sense to split up into teams of 5 or 10.
Yeah. I'm thinking it's easy to count screens, and if you can count and know that your application is going to be 20, 50 screens, and you can actually enumerate them, it's probably overkill. But it's such time where there's no way you can remember all the screens. You got to consult the master Excel spreadsheet to kind of itemize and chunk together all the different screens that this. Then maybe you're in that space, right?
Yep. I think if anyone listening has used Amazon before, they've probably seen that type of setup, because I think Amazon works exactly that way. It's absolutely Amazon.com is an absolutely enormous application.
Yeah.
And sometimes you click around and it feels like you're in a single page application. Things are requesting data and kind of refreshing within the same page. But other times you click on something and like the whole page disappears and refreshes server side,
Yeah.
And I think that's you kind of finding one of those edges between the apps.
Yeah. And Gmail and any of those massive ones. I was just adding a email alias to Google Mail, which I hadn't done in years. And it pulled up the old serif font, yellow background screen. I'm like, man, I hadn't seen one of those in a long time.
You found one of their legacy apps that hasn't been migrated.
Yeah, it's like maybe one of from the original version of Gmail.
Probably.
So it's funny.
Probably.
But hey, it worked, and no reason to upgrade that thing. So. Wow, this is good, Jay. I appreciate you coming on. I think we've probably gotten some imagination and architectural mental juices flowing in some of the listeners at possibilities. So, this is good stuff. There's so many challenges out there and good options to go along with them. So I appreciate you sharing.
Yeah, it's my pleasure. Thanks for having me on.
Oh, mine, all mine indeed. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.